everyone, in this video we will be seeing about iron sulfur protein. So already we have seen ferredoxin, which contain only one iron atom in them. Today we will be seeing about ferredoxin, which contains more than one iron atoms in their structure. So based on the number of iron atom, it can be classified. So generally what is ferredoxin means? It is an iron sulfur protein and their main function is to transfer electrons. So this is a non-heme protein. What does it mean by non-heme? Means it is not containing a heme group. Heme group is nothing but the iron is the metal and this will be surrounded by a porphyrin part with various substituents. That type of arrangement, that type of metalloporphyrin is not present in this case. That's why it is a non-heme protein. And as I have already mentioned, it contains more than one iron atoms. So, in all of their structure, each ion is surrounded by 4 sulfur atoms. So, firstly, we will be seeing about Fe2S2 ferredoxin. So, a 2Fe2S cluster. So, this is the structure. As you can see, 2 Fe are bridged by the sulfur groups. And there is also sulfur groups that are attached from the cysteine. So each Fe is surrounded by 4 sulfur atoms in here, as you can see. These 2 sulfur, which are in their bridged position, are labile in nature. Labile means they are in their S2 minus state, that is the free state. And these sulfur atoms that are coming from the cysteine group are not labile. That is, they are not in their free state, they are not in S2 minus state, but they will have a charge of -1. But these 2 Fe will be connected by this sulfido group, which is very labile. That's why it is mentioned 2S, because this sulfur is mentioning only the labile sulfur here. So here labile sulfur is only 2. And this type of ferredoxin is in 2 forms, either in oxidized form or in their reduced form. Another thing you have to see is these 2 Fe will be antiferromagnetically coupled via this sulfido bridge. So this is the structure of S-platinensis ferredoxin, and this is the protein part and this is the active center part. This will be looking like this. So first we will be seeing about their oxidized form. In the case of oxidized form, both the Fe are in their +3 state. So we know the electronic configuration, it is argon 3d6 4s2. In the case of Fe3 plus state, 3 of the electron is lost, so it is 3d5. So it contains 5 electrons each, and these are antiferromagnetically coupled via this sulfur atom that is present in their bridging position. And both of the Fe are in their high spin state. In the entire ferredoxin, all the Fe are in their high spin state only. So then we can calculate the charge of this part alone, not the entire cluster. We can calculate the charge of this part. And how do we calculate it? So this is the charge of the Fe. So while calculating the charge, we will add up the charge donated by each atoms. So initially +3, this is from Fe, and then this is +3, this is another from Fe, and each sulfur, since it is a labile sulfur, each will donate -2 charge. So -2, -2, and the entire charge will be now +2 for this part alone. And then they are diamagnetic because S is equal to 0. All of them are now paired. Paired means diamagnetic. Since there is no unpaired electron, it is also ESR inactive, because ESR active means there should be paramagnetic nature in them. Then only it is ESR active, but this is diamagnetic, so it is ESR inactive. So coming to the reduced form, in the case of reduced form, only one electron is gained by one of the iron atom, and this is converted into Fe2 plus state. Fe2 plus state means the total number of electron is now 3d6. So this is the oxidized form. It has gained one electron and converted into the reduced form. So in this case, here it is containing 5 electron and here it is 6 electron. Already here one is paired. You know how to arrange, right? So already here 1 is pair and there is 4 unpaired electron here. That will pair with this, and rest you will get 1 S is equal to 1 by 2. From this what you can know is there is 1 unpaired electron, so it is paramagnetic in nature. Since it is paramagnetic, it is ES or active. They have also noticed that there is an increase in the Fe distance when it is converted into their reduced form. So all of the Fe are in their high spin state. So next, coming to the 3Fe4s form, we can also tell it like Fe3S4 ferredoxin. So it is not containing a cubane structure. With the cubane structure, if we have removed this part, then it will look like this. So this is the structure of this Fe3S4 ferredoxin. So this is also an electron transfer agent, and this can exist in two forms. One is the oxidized form and other is the reduced form. In this case, 3 of them are non-labile sulfur atoms. So these 3. So whatever is coming from the cysteine, so 1, 2 and 3. These 3 are non-labile sulfur atom, and whatever is making up the cube, 1, 2, 3, 4, these are labile. So there are 4 labile sulfur atom. That's why it is mentioned 4s, because 4 of the sulfur atom that is making up the cube is labile in nature. They have found this type of cluster in A, vinyl and D. So first we will see about the oxidized form. In the case of oxidized form, all the 3 of them are in their +3 state. Since it is +3, there is 5 electrons and all of them are in their high spin, and as you know there is antiferromagnetic coupling. So there is antiferromagnetic coupling between 2 of the Fe3+ state atoms, and rest 1 is left without any pair. So each one will give +1 by 2. It will be counted as +5 by 2, and hence there is unpaired electron. So it is paramagnetic and it is also ES or active. So coming to the reduced form, in the case of reduced form, 1 electron is accepted by one of the Fe atom and one of them is converted into their +2 state, and all of them are in their high spin state. 2 of them is having now 5 electrons and one is having D6 number of electrons. So these 2 are getting, that is the Fe3+ and 3+ is getting antiferromagnetically coupled, and hence S is equal to 0. This is left out. Already 1 is paired and there is 4 number of electrons that is unpaired. So 1 by 2 plus 1 by 2 plus 1 by 2 plus 1 by 2, it is 4 by 2. So it cancel out to give S is equal to 2. So now it is paramagnetic since it is containing unpaired electron, and it is also ES or active. So coming to the most important type of ferredoxin, that is 4Fe4s ferredoxin. So this is the structure of this ferredoxin, but it doesn't exactly look like a cube, but it is kind of a distorted type of cube. So this is the exact structure. It doesn't exactly look like a perfect cube. Okay. So why is it not very perfect cube? We will see later. So here, as you can see, 4 of the sulfur atoms are in their labile nature, that is making up the cube, and 4 of the sulfur atoms are from the cysteine and they are not labile. So that's why it is mentioned 4s, which is mentioning the labile sulfur. So this is containing a distorted cube. And this is containing 3 forms. Note it very clearly. All of them, whatever we have learned, it has containing only 2 forms. But here it contains 3 forms. And then the Fe distance was found to be 2.75 angstrom, and the sulfur distance was found to be 3.55 angstrom. So this is to know clearly about the structure. So this is the active part, and this is the surrounding protein part. From the protein, cysteine group is present, and cysteine group is containing the thio group, and the thio group is attached to our active part. So there are 3 forms. So this is the first form. In the first form, 2 of them are in their Fe3+ state and 2 of them are in their Fe2+ state. So in the case of Fe3+ state, they are in their D5 number of electron. they both will get antiferromagnetically coupled and their S is equal to 0. And here also similarly, two of them are in their Fe2 plus state, and both of them are having d6 number of electrons, and they will also pair up correctly, and it will be S is equal to 0. So entirely there is no unpaired electron, so it is diamagnetic, and all of them are in their high spin state. Since it is diamagnetic, it is ES or inactive. Now coming to the charge calculation. So we can also calculate the charge of this entire cluster. So that was -2. How to calculate this charge means, first we have to know the charge of this Fe4S4. So Fe4S4 N plus charge. That is, we have to know what is N. So here, so since Fe is in their plus 3 state, first plus 3, plus 3, plus 2, plus 2, and each sulfur present here or labile sulfur. Labile sulfur means it is donating -2 charge. So each sulfur is having -2 charge. So 4 sulfur are present in labile nature. So 4 to 8, so -8, and totally it counts to be +2 charge. So this is the charge of this Fe4S4. And then this SR. So here this S is in the non-labile nature. That is, this S is from the cysteine. Since they are non-labile, they have only -1 charge. They are donating only -1 charge each. So since there are 4 sulfur, it is -4. So +2 -4, it is -2. So the total charges add up to be -2. So this is the next form. In this case, everything is similar, but you can see the charge is -3. We will calculate how it comes. So here, only one Fe is in their +3 state. Rest of them are in their +2 state. As you can see, this +3 state and +2 is getting paired up, and their S is found to be +1/2. And these two Fe2 plus is getting antiferromagnetically coupled, and the S is equal to 0. Since there is unpaired number of electron, it is paramagnetic, and it is also ESR active, and all of them are in their high spin state. So how do we calculate the charge? So here Fe4S4, we have to calculate the N. So what is N? We have to know. So it initially +3, +2, +2 and +2, and each sulfur is labile, so they will donate -2 charge. So 4 to 8, and the entire count is now +1. And then to find the charge of the entire cluster, so initially +1, and this sulfur is from cysteine, which is not labile, and the charge donated by them is -1. So it is -4 because there are 4 non-labile sulfur. So -4 and +1, it is -3. So the entire charge is -3. So this is the third form of the cluster. Here the charge is -1. Here 3 of the Fe are in their +3 state, and one of them is in their +2 state. As you can see, there is antiferromagnetic coupling, and here S is equal to 0, and in this case S is equal to 1/2. So they are paramagnetic, and they are also ESR active. So this is a very unstable form of these 3 forms of ferredoxin. So this is really unstable. And how do we calculate the charge means, first we have to calculate this charge. So to find N, it is +3, +3, +3 and +2, and each S is donating -2, so -8, and it counts to be +3. And to find the entire cluster charge, initially +3 is donated by this Fe4S4, and later on this sulfur from the cysteine is not labile, so it is donating -1 charge each. So there are totally 4 sulfurs, so -4, and it's add up to give -1 charge. So that's it about the 3 forms. So as we know, while undergoing an electron transfer process, it has to be either in their oxidized form or in their reduced form. But there are 3 types of forms. So at what type of range, in what condition they will be, in what form they will be in. So we will be seeing that. So in the potential range of -650 to -250 millivolt, it is in this form. That is, this is the oxidized form and this is the reduced form. So if the range is around +350, Then this is the reduced form and this is the oxidized form. As you can see, in both the cases the reduced form is similar, but the oxidized form is different. So this type of exchange between these two forms is the Foster self-exchange process in inorganic chemistry. So there is also hydrogen bond between the sulfur atom that is present in this active part and the hydrogen atom from the peptide bond that is present in the protein surrounding this active part. So this is the amido part, that is, this is the peptide group, CONH group is present, and this is the hydrogen, and this hydrogen and the sulfur from the Fe is having a bond, so hydrogen bond. The sulfur from both the sulfur, the labile sulfur and the non-labile sulfur, all of them will have a hydrogen bond, as you can see here. So based on their oxidation states, based on their number of more oxidizing power forms, then the compressibility and elongation will be studied. So this was a crystallographic study. By using the synthetic models, they have studied this process. So when the cluster is having 3 Fe in their +3 state, that is in their highly oxidized form, they are more compressed. As you can see, this is really compressed in one side. But when there is only 2 Fe in their +3 state, it is lightly compressed, as you can see. But if there is only 1 Fe in their +3 state and rest 3 is in their +2 state, then it is a very reduced form. So here in this case, the one of the side is more elongated, as you can see here. So this is the structure mentioned here and the naming you can see here. So there is also 7 ferredoxin, 7-Fe ferredoxin and 8-Fe ferredoxin. I am not going into detail, but how it looks, we have it is there in books. So in the case of 7-Fe ferredoxin, it may be a cluster. It is like cluster of 4Fe 4s and 3Fe 3s, like they both have binding, and that will form this 7Fe cluster. And in the case of 8Fe cluster, this is found in P arrow genus, and this is binding between 2 4Fe 4s clusters. So this is the structure. This is one 4Fe 4s cluster and this is another one, and they are bound via this protein thing. So this is a primary structure and this is found in P arrow genus. So thank you, that's it for today. I hope you understand every concept very clearly. Thank you for watching. If there is any doubts or any queries, you can mention in comments. So I have took these from Inorganic Chemistry by Lipperdberg, and it is also in Jai Kumar. So these are my reference books. So thank you so much for watching.